applications with vectors, which means word problems. Ty Murray was a recent World Championship bull rider in the National Finals Rodeo in Las Vegas, Nevada. One of the most dangerous tasks, besides riding the bulls, is the job of getting the bulls back into their pens after each event. Experienced handlers dressed as clowns expertly rope the animals without harming them. Ty Murray has completed his competition ride, and the two rodeo clowns are restraining the bull to return it to the paddocks. Suppose one clown is exerting a force of 270 newtons due north, and the other is pulling with force of 360 newtons due east. What is the resultant force on the bull? So, we have one vector that is 270 newtons due north, and we've got one that is 360 newtons due east. We're going to take this north vector and we're just going to move the vector over here so that our vectors are tip to tail. And then our resultant is going to be the hypotenuse of this right triangle, which is very easy to find because we know how to do Pythagorean theorem. So the magnitude of this force vector that we're trying to find squared is going to be equal to 270 squared plus 360 squared. Pythagorean theorem. And so 270 squared plus 360 squared is equal to 202,500. And so we take the square root of that, which is equal to 450 newtons. So that would be the magnitude. And it also wants us to find this angle because a vector has both a magnitude and a direction. So we want to find this angle. We want to find the direction of the vector. And again, that's easy. We have a right triangle, so we can use SOHCAHTOA. So we have the opposite side and the adjacent side. We probably want to use tangent. So tangent theta is going to be equal to the opposite side 270 over the adjacent side 360. So theta is going to be the inverse tangent of 270 over 360. And plug that into your calculator. And that gives us an angle of 36.9 degrees. So this force vector F is 450 newtons, and the direction is 36.9 degrees north of east, right? Compared to the east, and compared to the x-axis here, which is due east, we would go 36.9 degrees north. So 36.9 degrees north of east. In physics, if a constant force F displaces an object, an amount represented by a vector d, it does work on the object. The amount of work is given by F dot d. So work is the dot product of the force vector and the displacement vector. So you guys should have talked about work in physics. I think the STAIR lab you did was about work. And so force is a vector and displacement is a vector, but work is a scalar, not a vector. And so the reason for that is that it's the dot product of two vectors, and the dot product of two vectors is a scalar. So Alvaro works for a package delivery service. Suppose he's pushing a cart full of packages weighing 100 pounds up a ramp 8 feet long at an incline of 25 degrees. Find the work done by gravity as the cart moves the length of the ramp. Assume that friction is not a factor. So this ramp is 8 feet long, and this is 25 degrees. The force vector, right, is 100 pounds going straight down. So there's nothing in the x direction and negative 100 pounds in the y direction. The displacement vector, we're going to need to use SOHCAHTOA to break this up into the x and y components. So x and y. X is going to be the cosine of 25, is x over 8, the adjacent over the hypotenuse. So x equals 8 cosine of 25, which is 7.25. Double check that. Yep. And y is going to be 8 sine 25, which is 3.38. So the displacement vector is 7.25 feet in the x direction and 3.38 feet in the y direction. Then the work done is going to be the dot product of these two, which is 7.25, 3.38. And so we multiply the x's together, 0 times 7.25, and we multiply the y's together, negative 100 times 3.38, and that is 0 minus 338 equals negative 338. And our unit here is apparently in foot-pounds, which is just one more reason why SI units are superior, because foot-pounds is an atrocious unit. Sometimes there's no motion when several forces are at work on an object. The situation where the forces balance one another out is called equilibrium. So an object is in equilibrium if the resultant force on it is 0. If the forces in all the directions cancel out. Ms. Davies is hanging a sign for her restaurant. The sign is supported by 2 lightweight support bars as shown in the diagram. If the bars make a 30-degree angle with each other and the sign weighs 200 pounds, what are the magnitudes of the forces exerted by the sign on each support bar? So what we can do, right here, the 2 bars, they make a 30-degree angle, but that doesn't give us that doesn't make a triangle that we can use. So what we're going to do is we're just going to move this vector here. So we have one vector that goes like this and one vector that goes like this, and then the FW can be the resultant vector. And so that gives us a triangle, and all of these vectors, all 3 of these vectors together kind of cancel out. So now, if this is 30 degrees, if this angle here is 30 degrees, these vectors are parallel, so this angle here also must be 30 degrees. So now we've got a triangle where we've got F2 here, and F1 here, and FW here, and we've got an angle, and so if we know the magnitude of one of these vectors, we can find the other 2 using SOHCAHTOA. So if we want to find the hypotenuse first, for this 30-degree angle, the 200 is the opposite side and we want the hypotenuse, so opposite and hypotenuse is going to be sine. So sine 30 is equal to 200 over F2. And to solve for F2, we need to multiply both sides by F2. So we get F2 sine 30 equals 200. And we're going to divide by sine 30. Sine 30. And that gets us that F2 is equal to 200 over sine 30, which is 400 newtons or pounds. This says pounds, this says newtons. Whatever. Units aren't important. And then we can do the same thing to find F1. F1 is going to be, we have, for this angle, 200 is the opposite, and F1 would be the adjacent, so that would be tangent. Tangent 30 equals 200 over F1. And if we rearrange this exactly the same way we rearrange this one, we're going to get that F1 is 200 over tangent 30, which is 346 newtons or pounds, whatever unit we're supposed to be using here. The lighting system for a theater is supported equally by two cables suspended from the ceiling of the theater. The cables form a 140-degree angle with each other. If the lighting system weighs 950 pounds, what is the force exerted by each of the cables on the lighting system? So again, we are going to move these vectors around so that they make a triangle. And so all three of these vectors, the resultant of these three vectors is 0. So we're going to, so if we take this x vector here and we just move it so that it's here instead, right? This whole angle would be 180 degrees. This angle is 140 degrees, so this angle is 40 degrees. And that's how we get this 40-degree angle. And then we're going to take this vector and put the 950 vector here. And so this gives us an isosceles triangle because both of the legs are x. And so we know these two angles, let's call them theta, have to be the same because isosceles triangle. So 40 plus 2 theta equals 180 degrees in a triangle, which means that 2 theta equals 140, which means that theta equals 70. So we get these two 70-degree angles. Two 70-degree angles here. And now we know all of the angles and we know one of the sides, which means that we can use the law of cosines. Law of sines. We could use the law of cosines too, but let's use the law of sines, is what I meant to say. That's easier. So we are trying to solve for x. So x over sine 70 equals 950 over sine 40. Multiply both sides by sine 70. So we get that x is 950 sine 70 over sine 40. And if you put all of that into your calculator, you're going to get 1,389 pounds. And that's it for applications of vectors. Tune in next time for parametric equations, which just sounds like loads of fun.